So why do we want to create digital twins? And what is it? Let's try to understand. For example, we have some process or object of the real world, and we want to know something about that object, and we add some sensor, the temperature sensor, video cam, pressure, whatever it is, some sensor that is sending to our infrastructure, sending some telemetry data. And let's split this nice picture into two parts, where on the left side will be the real world that contains object and a part of the sensor. And there is a digital world that contains our IT infrastructure that processes all that information, and the part of the sensor that is transforming this signal reading into something digital that can later be processed in our infrastructure. In the real world, we rarely handle only one object. We usually have multiple objects. And all these objects are part of some bigger system that's it. In digital world we have two main flows. One is for sensor provisioning, maintenance, that is done by a separate system usually, and one is for telemetry processing. So it includes telemetry collection, digital twins for processes on object, and usually there is a top one for the system of digital twins. Yeah. It's useful to add some classification of digital twins. First one, a sensor or devices that contains these sensors. The main task here is to provision and to maintain these devices, so we can be sure that the data is collected properly and so on. There are already solutions like in major platforms like Azure IIoT Hub and Amazon and others. The second part, the second class in our classification is when we try to twin some object or process from the real world. The main task here is state estimation. Usually it's done via some custom solution that either have a simulation model execution, machine learning model, inference, neural nets, or other stuff. The last part of our classification is system digital twins. Usually this system contains of multiple object or process, thus our twin system contains multiple twins of object or processes, and it also receives information from other systems external to from other enterprise solutions, and the main task here is conflict resolution between the information that we receive from our digital twins and other systems. And it's always some custom implementation. Digital twin based implementation. So what we need, actually what logical blocks do we need to implement any digital twin? So let's check the external parts. So there are signal streams. There can be multiple signal streams. So there is that there's something that comes in to the digital twin, and digital twin have at least two streams that it sends out. Its internal state or state changes, and some notification errors and other messages. Inside we have some sort of so inside we have some storage for signals. Of course we have state, some model that we will use to estimate the state, and it's usually we use some clock, so we can send information or update state according to this clock. For example, you might have signal streams that then the signals comes every second or something, but you don't want to output information about the state or state change every second, and every minute is more than enough for you. So that's why you have this clock to level the, we can say, impedance, time scale impedance of the incoming signal stream for the outcoming streams. Well, let's check one of the implementation that uses digital twin, that we used digital twin in. The goal of the project was to position all the we have this huge repair facility for the locomotives or trains, or the locomotives. You can see it here, here, and here, and also here. So this locomotive has different types. You can see that this one is definitely not like this one, and so on. So we need to estimate, so we need to understand what type of locomotive it is, what number does it have. It's somewhere over here, very, very small on this picture. What length does it have? It can be length of one unit like this, it can be longer, and so on. And we need to have it in real time and send it for some UI and analytical system, so it can be processed further. Let's dive deeper into data flows. So everything starts with video cams. We have multiple video cams. For each video cam we have a RSTP or real stream RSTP grabber. All these grabbers sends image information to our image processor. I simplified it here as one block, but there are like multiple blocks. They do these blocks determine train position, train type, train plate number. So like there are several separated data flows for each one. Then all this information goes to the digital twins block. Then all this information goes to digital twins block, this one. And this block contains three different types of digital twins. So for train, for railway, they contains all information about the trains, and for depot, like the master. digital twin. Of course, we have some information from external system that goes into our block, and we output information about state changes and states, so we can display it in UI, and of course some different stream of notification, errors, and stuff like that. So let's dive deeper into digital twins that we used in this project. First, let's see what data streams we have here. So it's halo tape position of each train that comes into the facility. Then it's a train model, and there's a train plate number. Now we have a train digital twin. The interesting fact of this twin is that it contains more than one aspect of the train. Its position speed, its model, its type, also length, and the plate number. Then we have a railway digital twin, and it contains all the train positions of all the train that are in this on this railway. And at the top we have a depot, repair facility digital twin. It contains the states of all railways in this depot. So the train digital twin is the estimator mostly. So our goal is to estimate position, estimate speed, and so on. However, the railway digital twin is more of the conflict resolution. So we can have some business rules here, like for example, there cannot be more than 3 trains on one railway, or that the head of the railway should not be bigger than the tail of the other train, and so on. So here comes the business logic. And on the digital twin we have we're trying to combine more information, and it's usually at this level when we have input from some external system that give us more information about the trains and other assets within this facility.